Let's talk about differential equations. A differential equation is just an equation with derivatives in it. Pretty easy, pretty straightforward. Here's one, y prime equals 2x. This is called a first order differential equation because it only has the first derivative in it. Here's another first order differential equation, only one, the first derivative is in it. Here we have a second order differential equation because you've got a second derivative and a first derivative. And you don't need the first derivative. As long as you have the second derivative, that makes it a second order differential equation. So let's verify that y equals e to the negative 3x plus 2x plus 3 is a solution to y prime plus 3y plus 6x plus 11. First thing we're going to need to do is figure out what y prime is. Boop, there's y prime. Negative 3e to the negative 3x plus 2. Now I want to plug it into y prime plus 3y and simplify. So let's see, I have a negative 3e to the negative 3x and a positive 3e to the negative 3x, so they'll cancel out. I have the 2 right here, and then I have a 6 and a 9. So we have 2 plus 6x plus 9, giving us 6x plus 11, which is exactly what I wanted. Yay! So we verified it. When we're looking for solutions of differential equations, we can have general solutions or particular solutions. This is a particular solution. The general solutions will have the plus c, where you've got a whole bunch of different possible solutions. And that gives us a family of solutions. Suppose I have the differential equation y prime equals 2x. We know one such solution is y equals x squared. But the general solution is y equal to x squared plus c. So we have a family of solutions, which are all these parabolas at different levels. Particular solution. Sometimes we're given some information about our differential equation. Suppose I know that y prime equals 3x squared minus 2x plus 1, and it goes to the point 1, negative 1. We'll be able to find a particular solution for this differential equation. The first thing I need to do is integrate both sides. Now notice I have plus c here. Officially you're integrating the left and the right, so you would have y plus c1 and this crap plus c2, but then you bring the c1 over here and you combine them. Arbitrary constant, arbitrary constant. So let's just throw one arbitrary constant over on the right. So my function is x cubed minus x squared plus x plus c. I know it goes to the point 1, negative 1. So plugging that in, y of 1 is negative 1. So I have 1 minus 1 plus c. So c is equal to negative 2. Plugging that back into my equation, the solution, the particular solution to this differential equation is x cubed minus x squared plus x minus 2. An initial value problem is just the same as a particular solution, except the point they give you is what happens when x equals 0 or t equals 0, what happens initially. So consider the initial value problem, y prime equals 2e to the x plus 3x squared minus 4, and y of 0 equals 4. I have my derivative, I integrate, so I get 2e to the x plus x cubed minus 4x plus c. Plugging in my initial condition, I can solve for c and get that c is equal to 2. Plugging that back into the equation I have up here, my final answer is y equals 2e to the x plus x cubed minus 4x plus 2. Another problem you probably remember with fond memories from Calc 1 is throwing things off buildings and up in the air. Standard linear motion question. So let's say I am throwing a water balloon off a building. You're standing on top of an 18-meter building and you toss a water balloon off with an initial velocity of 20 meters per second. Find the velocity at time t. What's the velocity at time t equal 2? And find its position at t equal 2. As you may recall, acceleration due to gravity is negative 9.8 meters per second squared. If you don't recall it, now you know. The derivative of velocity is acceleration, and the initial velocity, typically denoted v sub 0, is 20. Finding velocity, I'm going to integrate a of t to get negative 9.8 t plus c. I know the initial velocity is 20. I plug that in and solve for c and get c equals 20. So my velocity equation is negative 9.8 t plus 20. I want to know what the velocity is at t equal 2, so I plug it in and I get 0.4. which means the balloon is still going up because the velocity is positive. Now what you might have known or you might have figured out is the initial velocity is always going to be your c in these cases. So we can go ahead and say velocity is negative 9.8 t plus v naught. Now let's do position. Velocity is negative 9.8 t plus 20. I know derivative of position is velocity, and then my initial position is 18 because we are on top of an 18-meter building. To get position, I will integrate the velocity equation. I get negative 4.9 t squared plus 20t plus c. Again, that c is going to be the 18. Let's prove that, quote unquote prove it. Plug in S0 is 18. Plug in 0 for t, and we get c is equal to 18. Quelle surprise! So s of t is negative 4.9 t squared plus 20t plus 18. Position at time 2 seconds. Plug it in, I get 38.4. And like I said before with velocity, your position equation, the c will always end up being s sub 0 when you have the standard linear motion equation. So solving differential equations is not much more than what we've already done. We integrate. We just have a different name for it.